The probability of any event is this. P equals the number of ways you can succeed. I'll call that the number of successes. There might be more than one way to get the event you want, divided by the number of total ways there are to see an event play out. So you could have a number of ways to succeed, a number of total ways that's bigger, and the ratio of those is the probability of success. So let's use an example. What's the probability, first one here, what's the probability of not rolling a pair of even numbers? So not rolling a pair of even numbers. Well, here's what we have to do. We count up the number of the number of pairs of numbers that are not both even. So if I look here, I'm going to put check marks next to the ones that satisfy this rule. That one's good. That one's good. All these ones with 1 are good because they all have 1 as one of the numbers. That means it's not a pair of even numbers. Now with 2, I only have a few successes. That one, 2 and 3, 2 and 5. See, there's only 3 successes in the 2s. In the 3s, there's going to be 6 successes. In the 4s, there's only going to be 3 successes. So for this one, I would say, here are my odds. It's going to be 6 for the 1s, 3 for the 2s, 6 for the 3s, 3 for the 4s. I need a little room here. So we're going to have 6 chances when I'm in the 5s and 3 chances when I'm in the 6s. And if you count up how many different combos of dice there are, there's a total of 36. So this is the probability of not rolling a pair of even numbers. And that's going to be, I don't know, what do we got here? 27 over 36. Okay, so that would be my answer for this guy. Now that's kind of a painful way of doing it. One thing we could have also done, and I want you to consider this, is we could have said, forget this not. I want to know what the probability is of rolling a pair of even numbers. And for that you would say, okay, well there's no chance of it in the 1s. There's 3 chances in the 2s. There's 3 chances in the 4s and 3 chances in the 6s. So you'd say, okay, I've got 9 chances of rolling a pair of evens. Well, 9 out of 36. What's 1 minus 9 over 36? It's 27 over 36. So multiple ways to get at these if you want. I'd say pick whichever seems easiest to you. Next one, what's the probability of the sum of 2 dice being 5? Well, let's scrap our probability chart over here and start over again. Again, we're counting successes. So sum of 2 dice being 5. Here's 1. 1 plus 4. Next one is 2 plus 3. Next one is 3 plus 2, which isn't listed here. But you see, there's going to be 1 chance of it in the 1s, 1 chance of it in the 2s, 1 chance of it in the 3s. There'll be 1 chance in the 4s. There's no chance of it in the 5s because there's no chance you're going to roll a 5 and a 0. So for this one, you have 4 possible ways of doing this successfully out of 36 dice rolls. So that's your probability of the sum of 2 dice being 5. It's not a very likely outcome. And then the last one, what's the probability of the sum of 2 dice being a prime number? Again, this is going to take a little bit. You're going to have to make a table like this, probably, unless you just happen to be a dice genius or something. But you're probably going to have to make a table of this and just go through it and sum them up and say, is this a prime number? Is this a prime number? Is this a prime number, right? See, 1 plus 3, not a prime number. 1 plus 4 is, though. 1 plus 2 is also, so we got one right there. 1 plus 2, 1 plus 4. 1 plus 7 works. 2 plus 1 works. 2 plus 3, right? So you count up the number of ways to succeed at this, divided by the total number of combos possible, that's 36, and you'll have your probability.